Today let's discuss questions related to Lagrange's multiplier method, and this topic is one of the favorite topics of UPSC, as every year at least one question is asked from this topic. So let's see question one by one. So the question 1 says that find the maxima and minimum distance from the origin to the curve using Lagrange's multiplier method. So we are supposed to find the points on the given curve where the distance is maximum and minimum from the origin. So let us assume that x comma y be any such point. Such on the curve, then its distance from origin will be under root x square plus y square. Now we are supposed to maximize and minimize this distance with respect to this given curve. So let us define our function f as, if you notice that the maximum distance of this function and the point where the function achieves maximum distance will be same for this and this, likewise for minimum as well. So we will be using this function to avoid this under root thing and simplify our calculation a bit. So let us define our function f x comma y. So that will be x square plus y square plus lambda into 5x square plus 6xy plus 5y square minus 8. So this is our function f, and here lambda is basically the Lagrange's constant. So if we'll take its total derivative, we'll get 2x plus 10 lambda x plus 6y lambda into dx plus 2y plus 6x lambda plus 10y lambda into dy. Now we'll equate it with 0 to get the points where the function can achieve extremum values. So for that, this part, that is coefficient of dx, must be equals to 0, and the coefficient of dy also must be equals to 0. So from there we'll get 2x plus 10x lambda plus 6y lambda equals to 0, and 2y plus 6x lambda plus 10y lambda equals to 0. So if we simplify it for x, so from here we'll get x equals to minus lambda into 5x plus 3y, and from here we'll get y equals to minus lambda into 3x plus 5y. So from here, if I calculate value of minus of lambda, that will be x divided by 5x plus 3y, and from here also if I find out minus of lambda, that will be y divided by 3x plus 5y. Now I can equate these two values of minus lambda to get another relation in between x and y. So if I do so, I'll get x divided by 5x plus 3y equals to y divided by 3x plus 5y. Now if I cross multiply it, I'll get x into 3x plus 5y equals to y into 5x plus 3y. So from here I'll get 3x square plus 5xy equals to 5xy plus 3y square. This 5xy, we can balance out 5xy from both the sides, so we are left with x square is equals to y square. So from here I get my x is either equals to positive y or negative y. Now this is the relation between x and y, and from the question we know that our x and y point lies on this curve. So we'll use this and the relation that we got from got by equating minus lambda to find out values of x and y. So let's do that. So it is 5 of x square plus 6xy plus 5 of y square minus 8 equals to 0. Now case 1, when my x is equals to y, so it will reduce to 5x square plus 6x square plus 5y square minus 8 equals to 0. So from here I'll get 16x square equals to 8, that is basically x square equals to 1 by 2. So from here I'll get my x is equals to either plus or minus of 1 by root 2. So this give me 2 points, that is 1 by root 2 comma 1 by root 2 or minus of 1 by root 2 comma minus of 1 by root 2, because in this case I assume that y is equals to x. So let us take case 2. So in case 2 my x is equals to minus of y. So from here that is 5x square plus 6xy plus 5y square minus 8 equals to 0. If I substitute y equals to minus x, I'll get 5x square minus 6x square plus 5x square minus 8 equals to 0. That is 10 minus 6x square, that is 4x square equals to 8. So from here I'll get x equals to plus or minus under root 2. So this give me 2 points, that is under root 2 comma minus of root 2 or minus of root 2 comma root 2. So I have 4 points where the function can attain possible maxima or minima. Now I'll just substitute these points in the distance formula and see which basically gives me the maximum and minimum distance. So my distance is basically under root x square plus y square. So at points 1 by root 2 comma 1 by root 2 and minus 1 by root 2 comma minus 1 by root 2, my distance d is equals to under root 1 by 2 plus 1 by 2, that is 1. And my distance at root 2 comma 1 by minus root 2 and minus root 2 comma root 2, my distance is basically under root 2 plus 2, that is under root 4, which is 2. So this is the maximum possible distance that function, maximum possible distance of curve from the origin, and this is the minimum possible distance of the curve from origin. So maximum distance from origin is 2 unit and minimum distance from origin is 1 unit. Now let's move on to the next question. So the next question says that using the Lagranges Multipliers method, find the minimum and maximum distances of this point from the given sphere. So what we'll do is we'll assume that the maximum and minimum distances are attained at point x comma y comma z, and then we'll use the distance formula and this as basically the given condition. So let us define our function f, that will be basically x minus 2 square plus y minus 6 square plus z minus 3 square plus lambda into x square plus y square plus z square minus 4. So this is the function f. Now let's differentiate it with respect to x. Let's take its total differentiation, that will be basically 2x minus 2 plus 2x lambda into dx plus 2y minus 6 plus 2y lambda into dy plus 2z minus 3 plus 2 lambda z into dz. So to get the possible critical points, or the points where function can achieve maximum values, we need to equate the total derivative, that is df, with 0. So that basically gives us 2 into x minus 2 plus 2x lambda equals to 0, 2 into y minus 6 plus 2y lambda equals to 0, and 2 into z minus 3 plus 2z lambda equals to 0. Now from here what I can do is I can simplify it. It will basically give me 2x into 1 plus lambda is equals to 4, and from here I'll get 2y into 1 plus lambda is equals to 12, and from here I'll get 2z into 1 plus lambda is equals to 6. So from here I can easily find out relation in between x, y and z. So if I just let's name it as 1, this as 2, and this as 3. So if I divide 1 by 2, so I'll get x by y equals to 4 by 12. That basically gives me x by y equals to 1 by 3. Likewise, if I divide 2 by 3, so I'll get y by z equals to 12 by 6. So from here I'll get my y by z is equals to 2. So from what I can do is from here I can calculate value of x in terms of y, that is y by 3, and from here I can calculate value of z in terms of y, that is y by 2. Now we know that from the equation that the points x, y and z lies on the given sphere of radius 2 and center 0, 0, 0. So I'll just substitute these x, y, z in the given sphere, that is x square plus y square plus z square equals to 4, but my x is y by 3, so it will be y by 3 square plus y square plus z, that is y by 2 square is equals to 4. So if I simplify it, I'll get y square into 1 by 9 plus 1 by 4 is equals to 4. This basically gives me y square is equals to 36. 4 plus 36 plus 9 is equals to 4. From here I'll get y square equals to 4 into 36 divided by 49. So that basically gives me y as plus minus 2 into 6 divided by 7, that is plus minus 12 by 7. So my points where function can attain maximum or minimum distance on the sphere from the given point P, that is 2, 6, 3, can be x is basically y by 3, so that will be plus minus 4 by 7, y is plus minus 12 by 7, and z is plus minus 6 by 7. So we got 2 points. Let's name them as A and B. So my point A is 4 by 7, 12 by 7 and 6 by 7. Likewise, my point B will be minus 4 by 7, minus 12 by 7 and minus 6 by 7. Now we'll just calculate the distance of AP and BP and see where the function where the point is from, which point is from minimum distance and which point is from maximum distance from P. So my AP will be basically, my P is 2, 6, 3. So my AP will be 2 minus 4 by 7 square plus 6 minus 12 by 7 square plus 3 minus 6 by 7 square. Likewise, my BP will be basically under root 2 plus 4 by 7 square plus 6 plus 12 by 7 square plus 3 plus 6 by 7 square. So you can clearly observe that distance BP is greater than AP. So at point B, are we supposed to find the minimum and maximum distances? So these are basically the minimum distances. So at point B, B is at maximum distance from P, and A is at minimum distance from P, and the respective distances are basically, we can just simplify it. So what we'll get is 7 square, 14 minus 4, 10 square, plus 42 minus 12, 30 square, plus 21 minus 6, that is 15 square. So this basically gives me 35 by 7, that is 7 into 5, that is 5 units, and this distance will be basically under root 7 square into 7 2s are 14 plus 4, that is 18 square, plus 6 7s are 42 plus 12, that is 54, plus 7 3s are 21, plus 6, that is 27. So this is basically 63 divided by 7. So this basically gives us 9. So this is 5 units and this is 9 units. So B is basically at maximum distance from P, and distance is basically 9 unit, and minimum distance is 5 unit. So that's all we are supposed to find in this question. So let's move on to the next question. So the next question says that a wire of length L is cut into two parts which are bent in the form of a square and a circle respectively, and we are supposed to use the Lagranges method of undetermined multipliers. Find the least value of sum of the area so formed. So we have this is basically, in this question they have specified to use Lagranges method, and this is basically a repeated question. Earlier they have asked this question, earlier also they have asked this question, but that time they didn't specify to use Lagranges method. This time they have specifically mentioned to use Lagranges method. So if this is a wire of length AB, let's say, and it is given that it is of length L and it is cut at some point, let's say C. So if my distance AC is X, then my distance BC is basically L minus X, because whole length of whole wire is L. So it further says that the two parts, one of them is bent in the form of a square. So let us assume that let AC is bent in square form, and CB is bent in circle form. So if AC is bent in square form, then let us assume that YB basically the length of the square. So if y is length of the square, then parameter of square will be basically 4 times y, and that must be equals to the length x. Likewise here parameter of circle, if we assume r to be the radius of circle, then parameter will be 2 pi r, and this must be equals to length L minus x. So the parameter of the given figures is fixed. Parameter of AC plus CB is fixed, that is basically 4y plus 2 pi r, and we are supposed to find the least value of sum of areas. So sum of areas will be area of a square is basically side square, and side we have assumed to be of length y, so area of square will be y square. And likewise we have assumed the radius of circle as r, so area of circle will be pi r square. Now let us form a formula as a, that will be basically y square plus pi r square plus lambda times 4y plus 2 pi r. So here lambda is basically undetermined multiplier or maybe Lagrange's coefficient, and we are supposed to minimize this area, minimize this sum of areas. So for that, first let us take the total differential, that will be basically 2y plus 4 lambda into dy plus 2 pi r plus 2 pi lambda into dr. So to get the points like where it attains the minimum area, we just need to equate the area with 0. So that basically gives us 2y plus 4 lambda equals to 0 and 2 pi r plus 2 pi lambda equals to 0. So if I simplify it, I'll get my lambda as minus y by 2, and from here I'll get my lambda as negative of r. So I got a relation in between a lambda in between r and y, that is basically minus of y by 2 is equals to minus r, that is y is equals to 2r. So what that means is basically length of the square formed is twice the radius of the circle. Basically length of square is same as diameter of the circle formed. Now we are supposed to minimize this area. So for that let's just take double derivative of area, that is the a function that we formed, and see if this relations take us somewhere. So that will be basically equals to 2 into dy square plus 2y plus 4 lambda into d square y plus 2 pi into dr square plus 2 pi r plus 2 pi lambda into d square r. Now using this relation, that is y equals to 2r, I can easily find out value of y and r in terms of some constant, because my parameter that is equals to this is a constant thing, it is equals to total length of wire. So I can use this relation to get the values of y and r. So my relation is L is equals to 4y plus 2 pi r, but my y is 2r, so it will be 4 into 2r plus 2 pi r. So from here if I simplify it, I'll get my r as L divided by 8 plus 2 pi, and if I calculate my y, then my y will be basically, y is basically 2 times of r, so that will be L divided by 4 plus pi. So I got values of basically y and r. Now I can use these values here in the double derivative, that is d square a, to see if it is greater than 0 or less than 0. Based on that we'll conclude whether the area for these length is a maximum or minimum. So it will be 2 into dy square plus 2 times of y, that will be 2L divided by 4 plus pi plus 4 into lambda. Lambda is basically negative of r, that is minus L divided by 8 plus 2 pi into d square y plus it is 2 pi into dr square plus 2 pi into r plus lambda, and from here r plus lambda is basically 0, so I'll just substitute 0 only, so it is d square r. So this thing simplifies to 2 into dy whole square plus 2 pi into dr whole square plus if I simplify it, I'll get 2L divided by 4 plus pi minus 2L divided by 4 plus pi into d square y, and this balances out this. So it basically d square a is basically 2 dy square plus 2 pi into dr square, and this thing is greater than 0 at r equals to L divided by a plus 2 pi and y equals to L divided by 4 plus pi. So at for these values of basically y and r, the area is minimum. Or least, and that's what I guess we're supposed to show using find the least value of sum of area. We are also supposed to find the basically value, what will be the value of sum of area. So let's do that. So value of area will be value of least area will be basically y square plus pi r square. So that will be y is basically L divided by 4 plus pi square plus pi into r square, that is L divided by 8 plus 2 pi square. So from here I can take L square by 4 plus pi square as common, so I will be left with 1 plus pi divided by 4. So that basically gives me L square divided by 4 plus pi square into 4 plus pi divided by 4. This 4 plus pi balances this, so my area will be L square by 4 into 4 plus pi. So this is basically the least area that can be formed by dividing length of wire L into two parts, of which one is bent into a square and other is bent in a form of a circle. So let's move on to the next question. So the next question says that find the maximum and minimum values of this function when this holds and this holds, and we're supposed to further interpret the result geometrically. So in the question they have given us a function f that will be basically x square by a raised 4 plus y square by b raised 4 plus z square by c raised 4 plus lambda 1 into lx plus my plus mz plus lambda 2 into x square by a square plus y square by b square plus z square by c square minus 1, and we are supposed to basically find the maxima and minima value of this. So for that, to find basically the points where it can attain maxima or minima, let's just take total derivative of f. So that will be basically 2x by a raised 4 plus L lambda 1 plus 2x lambda 2 by a square into dx plus 2y by b raised 4 plus m lambda 1 plus 2y lambda 2 by b square into dy plus 2z by c raised 4 plus n into lambda 1 plus 2z into lambda 2 by c square into dz. So to get basically the points where it can attain maxima and minima value, we need to equate this total derivative with 0. So that basically gives us 2x by a raised 4 plus L lambda 1 plus 2x lambda 2 by a square is equals to 0. Likewise 2y by b raised 4 plus m dot lambda 1 plus 2y lambda 2 by b square equals to 0, and 2z by c raised 4 plus n dot lambda 1 plus 2z lambda 2 by c square equals to 0. So I got these relations and I need to conclude some values for lambda 1 and lambda 2 from here to move ahead. So for that, what I can do is, first let's just name these equation as 1, 2 and 3. So if I multiply 1 with x and then add it to 2 multiplied by y and then 3 multiplied by z, so I'll get 2 into x square by a raised 4 plus y square by b raised 4 plus z square by c raised 4 plus lambda 1 into lx plus my plus nz plus lambda 2 I can take 2 lambda 2 common here, so I'll be left with x square by a square plus y square by b square plus z square by c square equals to 0. And in the question, this term is given to me as 0 and this term is given to me as, this is basically equals to 1. So from here I'll get 2 times x square by a raised 4 plus y square by b raised 4 plus z square by c raised 4 plus this term will reduce to 0, so I'll be left with plus 2 lambda 2 equals to 0. So and this is the term for which we are supposed to find the maximum and minimum value. So let us name this term as u for time being. So let x square by a raised 4 plus y square by b raised 4 plus z square by c raised 4 equals to u. We are naming it just so that we don't need to write it again and again, because it will be involved in a lot of calculations. So from here, if we replace it with u, we'll get 2u plus 2 lambda 2 equals to 0. So from here I'll get my lambda 2 as minus of u. Let's name this as equation 4. Now if I use this value of lambda 2 in any of the equation 1, 2 and 3, so what I'll get is 2x using it in 1. So I'll get 2x by a raised 4 plus L lambda 1 plus 2x lambda 2 by a square equals to 0. So if I substitute lambda 2 equals to minus u, I'll get 2x by a square into 1 by a square plus lambda 2 plus L lambda 1 equals to 0, and lambda 2 is basically minus u, so that will give me 2x by a square into 1 by a square minus u plus L lambda 1 equals to 0. So from here what I can do is, I can write value of x in terms of other variables, other constants, so that will give me x equals to minus L lambda 1 into a raised 4 divided by 2 into 1 minus u a square. Likewise, if I find value of y by substituting this lambda 2 in equation 2, so I'll get my y as minus m lambda 2 b raised 4 divided by 2 into 1 minus u b square. You can just substitute this value of u in equation 2, or you can just observe the symmetry and write it directly. So z will be basically minus n lambda 2 c raised 4 divided by 2 into 1 minus u c square. So these are the basically values of x, y and z. Now we have a relation already with us that says that L of x plus my plus nz equals to 0. So we'll just substitute these values therein and see if we'll get some relation from there. So we have Lx plus my plus nz equals to 0, and x is my minus L lambda 1 a raised 4 divided by 1 minus u a square plus m into minus m lambda 2, here it is lambda 1 and here also it's lambda 1, minus m lambda 1 b raised 4 divided by 2 into 1 minus u b square plus n into minus n lambda 1 c raised 4 divided by 2 into 1 minus u c square equals to 0. So if I simplify it, I can take minus lambda 1 by 2 common from the whole equation. So I'll be left with L square into a raised 4 divided by 1 minus u a square plus m square into b raised 4 divided by 1 minus u b square plus n square into c raised 4 divided by 1 minus u c square equals to 0. So from here I'll get this is just a constant thing, so I can just eliminate it. So the relation left with me is L square into a raised 4 divided by 1 minus u a square plus m square into b raised 4 divided by 1 minus u b square plus n square into c raised 4 divided by 1 minus u c square equals to 0. So if you will take its LCM and simplify it, you will see that it will give us a quadratic equation in U. A quadratic equation in terms of U, and we have assumed our U is equals to x square by a raised 4 or a square. X square by a raised 4 plus y square by b raised 4 plus z square by c raised 4. So that quadratic equation, if you will solve that quadratic equation, we'll get basically two values of u. So from here we'll get two values of u. One of them will be basically the maximum value and other one will be the minimum value of u. One of them is maximum value and second one is minimum value. So this is one thing that we are supposed to do in this question. Further in the question it says that interpret the result geometrically. So we are supposed to interpret what this result actually means. So if you see that in the question they have given us a equation of ellipsoid and a equation of plane, and we are supposed to maximize or minimize this distance. So if this is my equation of ellipsoid, my equation of ellipsoid is basically x square by a square plus y square by b square plus z square by c square equals to 1. So equation of any tangent plane at some arbitrary point, let's say alpha, beta, gamma, will be basically x alpha by a square plus y beta by b square plus z gamma by c square equals to 1. This will be basically the equation of tangent plane. Now if I find its distance, like basically the distance of tangent plane from origin, perpendicular distance of tangent plane from origin, that will be basically 1 divided by alpha square by a raised 4 plus beta square by b raised 4 plus gamma square by c raised 4. This is basically the perpendicular distance of this tangent plane at alpha, beta, gamma from origin. And if you observe that this is basically the value which we are supposed to maximize or minimize. So what we are basically asked in the given question is, if our point basically, let's say alpha, beta, gamma lies on a certain problem, then we are supposed to basically lies on a certain plane, and the plane is given to x as lx plus my plus nz equals to 0, and we are supposed to basically maximize and minimize the perpendicular distance from origin to that tangent plane to the ellipsoid, basically this. So that's the question. So let's move on to the next question. So the next question says that Using Lagrange's undetermined multipliers method, find the volume of the greatest rectangular parallelepiped that can be inscribed in this ellipsoid. So we are supposed to maximize the volume of rectangular parallelepiped. So let us assume that x, y and z be length, breadth and width of the length, breadth and height. Length, breadth and height of rectangular parallelepiped. Then volume of rectangular parallelepiped will be volume of rectangular parallelepiped will be basically xyz, and we are supposed to maximize this volume such that this rectangular parallelepiped can be inscribed in this given ellipsoid. So if let's say this is x-axis and this is y-axis and this is z-axis, and let's say this is any ellipsoid on it, and we are supposed to fit in a rectangular parallelepiped of a maximum volume inside it. So we are supposed to basically tell the maximum volume rectangular parallelepiped that can be inscribed in this given ellipsoid. So let us form the function f that will be basically xyz, that is the part which we are supposed to maximize, and in this case that is volume of rectangular parallelepiped plus Lagrange's multiplier into the given condition, that is x square by a square plus y square by b square plus z square by c square minus 1. Now if we take its total derivative, that will give me yz plus 2x lambda by a square into dx plus xz plus 2y lambda by b square into dy plus xy plus 2z lambda by c square into dz. So if I equate it with 0, so that basically gives me yz plus 2x lambda by a square equals to 0, xz plus 2y lambda by b square equals to 0, and xy plus 2z lambda by c square equals to 0. Let's name these equations as 1, 2 and 3. Now if I just multiply 1 with x and 2 with y and 3 with z and just add these three, so I'll get 3xyz plus 2 lambda into x square by a square plus y square by b square plus z square by c square equals to 0. But this term is basically equals to 1. So from here I'll get 3xyz plus 2 lambda equals to 0. So that basically gives me lambda equals to minus 3xyz by 2. Now if I just substitute this value of lambda in any of the equation 1, 2 or 3, so what I'll get is, let's substitute it in 1. So if I substitute it in 1, so I'll get yz plus 2 lambda x by yz plus lambda x by a square equals to 0. So from here I'll get yz plus 2x by a square into lambda, that is minus 3xyz by 2 equals to 0. This 2 balances this, and I can just take yz common throughout, so that basically gives me yz into 1 minus 3x square by a square equals to 0. So if I solve it, either I'll get my y equals to 0 or z equals to 0 or this term equals to 0. But if I'll take my y and z equals to 0, then that basically gives me volume of parallelepiped as 0. So we'll just eliminate these cases and we'll focus on the third part. That basically gives me x equals to a by under root 3. I'm just taking the positive value because length of a parallelepiped cannot be negative. So from here I got my x as this. Likewise, if I'll substitute this value of lambda in equation second, I'll get my y as b by root 3, and if I substitute this value of z in equation 3, I'll get my z as c by under root 3. So this is the point x, y and z that I got. So from here x, y and z is basically a by root 3, b by root 3 and c by root 3. Now if I calculate volume of parallelepiped here, so that will be ABC by 3 root 3. But now I am supposed to check like whether this will be the greatest possible value of the parallelepiped. For that I need to verify that at this point xyz del square f is less than 0. So let's move on to the next question. So it says that find the stationary values of this subject to the conditions this and this and interpret the result geometrically. So it is the same question that we have, like it is kind of a repeated question, but in earlier question like the ellipsoid was basically x square by a square plus y square by b square plus z square by c square, and we are supposed to calculate basically the values of x square by a raised 4 plus y square by b raised 4. So it's kind of similar question. It's just the values of basically the ellipsoid is changed and this term is changed. So for that you need to assume the function f. So that will be basically equals to x square plus y square plus z square plus lambda 1 into a x square plus by square plus cz square minus 1 plus lambda 2 into lx plus my plus nz. Yeah, so if we take its total derivative, we'll get 2x plus 2ax lambda 1 plus l lambda 2 into dx plus 2y plus 2by lambda 1 plus m lambda 2 into dy plus 2z plus 2cz lambda 1 plus n lambda 2 into dz. So if I equate df with equals to 0, so I'll get 2x plus 2ax lambda 1 plus l lambda 2 equals to 0. Likewise 2y plus 2by lambda 1 plus m lambda 2 equals to 0 and 2z plus 2cz lambda 1 plus n lambda 2 equals to 0. Let's name these equations as 1, 2 and 3. So if I just multiply 1 with x, 2 with y and 3 with z and just add these three equations, so I'll get 2 into x square plus y square plus z square plus 2 lambda 1 into ax square plus by square plus cz square plus lambda 2 into lx plus my plus nz equals to 0, and this term is given to us as 0 in the question, so it will reduce to 0 and this term is equals to 1. So what we'll get is 2 times x square plus y square plus z square plus 2 lambda 1 equals to 0, and this is the value for which, like this is the function whose value we are supposed to find. So let's name it as u for time being. So it is x square plus y square plus z square. So from here I'll get, if I simplify it, I'll get my lambda 1 as minus of u. Now if I just substitute this value of lambda 1 in equation 1, that is substituting a value of lambda 1 in equation 1. So what I'll get is 2x plus 2ax lambda 1 is basically minus u plus L lambda 2 equals to 0. So if I solve it for x, I'll get x equals to minus L lambda 2 divided by 2 into 1 minus au. Likewise, if I substitute this in equation 2, I'll get my y as minus m lambda 2 divided by 2 into 1 minus bu. And if I substitute in equation 3, I'll get my z as minus n lambda 2 plus 2 into 1 minus cu. So these are the values of x, y and z. But in the question it is given to me as Lx plus my plus nz equals to 0. So if I just substitute these values of x, y and z herein, so I'll get L into minus L lambda 2 by 2 into 1 minus au plus m into minus m lambda 2 divided by 2 into 1 minus bu plus n into minus n lambda 2 divided by 2 into 1 minus cu equals to 0. So if I just take minus of lambda 2 common, so I'll be left with L square. Let's take minus lambda 2 by 2 common, so I'll be left with L square by 1 minus au plus m square by 1 minus bu plus n square by 1 minus cu equals to 0. And this is just a constant term. So from here I'll get L square by 1 minus au plus m square by 1 minus bu plus n square by 1 minus cu equals to 0. So if you'll simplify it, you'll get basically a quadratic equation. A quadratic equation in u, and you can just solve it for values of u. So that will basically give me two values of u. One will be basically the maximum value and another will be minimum. So these will be basically the stationary values, and further in the question it asks us to basically interpret the result geometrically. That will be same as we have done in previous question, that is it will be the perpendicular distance to any tangent from origin, basically the perpendicular length of the tangent plane from origin. So let's move on to discuss the next question. So the next question says that find the shortest distance between this line and the ellipse this using the Lagranges multiplier method. So we are supposed to find shortest distance between the line that is y equals to 10 minus 2x and the ellipse that is x square by 4 plus y square by 9 equals to 1. So let us assume that let alpha comma beta be any point on the ellipsoid. Be any point on ellipse. So if it is a point on ellipse, then it must satisfy the equation of ellipse. So from there I'll get alpha square by 4 plus beta square by 9 is equals to 1. So let's name this equation as equation number 1. And we're supposed to basically find the distance between this point P. So we assume this point to be the point such that it's shortest distance from line, such that it is shortest distance from line. So basically the shortest distance will be 2 times of beta sorry 2 times of alpha plus beta minus 10 under root basically 2 square plus 1 square, because equation of our line is y is equals to 10 minus 2x, and you can basically use the distance formula directly. Now we are just supposed to find the values of this point alpha and beta. So let's define a function f that will be basically 2 alpha plus beta minus 10 divided by under root of 5 plus lambda times alpha square by 4 plus beta square by 9 minus 1. Now if I take its total derivative, that will be basically 2 by under root 5 plus 2 alpha lambda by 4 into d alpha plus 1 by under root 5 plus 2 beta lambda by 9 into d beta. Now if I just equate it with equals to 0, so from here I'll get 2 by under root 5 plus 2 alpha lambda by 4 equals to 0 and 1 by under root 5 plus 2 beta lambda by 9 equals to 0. From here I can just calculate value of alpha and beta in terms of lambda, and we already have a relation for alpha and beta that is given by equation 1, so that will basically give us the value of lambda, and then we can just find out the specific values of this. Basically the specific values of alpha and beta. So if I just calculate alpha from here, that will be minus 2 by 5 root 5 into 4 by 2 lambda, that is basically alpha equals to minus 4 by lambda root 5. Likewise from here if I find beta, that will be minus 1 by root 5 into 9 by 2 lambda. So my beta will be minus 9 by 2 lambda under root 5, and I know that alpha square by 4 plus beta square by 9 is equals to 1. So that basically gives me 16 by lambda square into 5 into 1 by 4 plus 1 by 9 into beta square will be 91 into 4 lambda square into 5 equals to 1. So this basically gives me 9, and I can just take 5 lambda square common, 1 by 5 lambda square common, so I'll be left with 4 plus 9 by 4 equals to 1. So from here my lambda square will be equals to 1 by 5 into 16 plus 9 by 4. So lambda square will be 25 by 5 into 4, that is basically that basically gives me lambda is plus minus under root 5 by 2. Now I got my value of lambda, so that basically gives me alpha equals to minus 4 by under root 5 into lambda, that is plus minus root 5 by 2. That basically gives me alpha as minus plus 4 to 8 by 5 and beta as minus 9 by 2 root 5 into lambda, that is plus minus root 5 by 2. This 2 balances this, so my beta will be basically minus plus 9 by 5. So I got these two values of alpha and beta, and now I just need to verify like for which value of alpha and beta distance is basically minimum. So we have two values, that is minus 8 by 5 and minus 9 by 5, and 8 by 5 and 9 by 5. So if you'll just substitute positive values, then you'll get basically the, so let's just calculate distance. So distance d will be basically d at basically minus 8 by 5 and minus 9 by 5 will be basically equals to 2 alpha plus beta minus 10 2 into alpha plus beta, that is minus 9 by 5 minus 10 divided by under root 5, and this is equals to minus 16 minus 9, that is minus 25 by 5 minus 5 minus 10 minus 15 by under root 5, that is minus 3 root 5, and distance at 8 by 5 comma 9 by 5 will be 16 by 5 plus 9 by 5 minus 10 divided by under root 5, that is 25 by 5, which is 5 minus 10, that is minus 5 by root 5, that is minus root 5. So this is the minimum distance at the point 8 by 5 comma 9 by 5. The ellipse is at least distance from the given line. So let's move on to the next question. So the next question says that find the extreme value of the function u subject to this condition using Lagrange's method of undetermined function. So let's define our function f, that will be basically x square plus y square plus z square plus lambda times 2x plus 3y plus 5z minus 30. So if I simplify it, I'll get del df as 2x plus 2 lambda dx plus 2y plus 3 lambda into dy plus 2z plus 5 lambda into dz. Now to get the critical points, let's equate it with 0. So that basically gives me x equals to minus lambda, y equals to minus 3 lambda by 2 and z equals to minus 5 lambda by 2, and we have already a relation in between x, y and z, so we can just substitute these parametric values of x, y and z to get value of lambda. So that is basically 2x plus 3y plus 5z equals to 30. So it will be 2 into minus lambda plus 3 into minus 3 lambda by 2 plus 5 into minus 5 lambda by 2 equals to 30. So if I simplify it, I can just take out minus lambda common. So I'll be left with 2 plus 9 by 2 plus 25 by 2, and I can write it as 4 by 2 is equals to 30. So from here minus of lambda is 25 plus 9, that is 34. 34 plus 4 is 38 by 2 equals to 30. So from here I got my lambda as minus 30 by 19. So this is basically the value of lambda. Now if I just calculate del square f, that will be 2 times dx square plus 2 times dy square plus 2 times dz square, and which is greater than 0 for all x, y and z. So it will be greater than 0 for x, y, z where lambda is this. So my extreme value will be basically extreme value is attained at x equals to minus lambda, that is 30 by 19, y equals to minus 3 by 2 into lambda, and z equals to minus 5 by 2 into lambda. So my value of u will be basically the extreme value of u will be x square plus y square plus z square, and here x, y, z are basically these values. So if I just substitute value of x, that will be 30 by 19 whole square plus 33 is 90 by 38 whole square plus 35 is 150 by 38 whole square. So that basically gives me 60 square plus 90 square plus 150 square divided by 38 square. So this thing will be equals to So if you calculate it, this thing will be basically equals to 34200 divided by 4 into 19 into 19. So if you divide it by 4, you will basically get 8550 divided by 19 square, and that further equals to 450 divided by 19. So this is basically the extreme value of u, and it is attained at these points, like these values of x, y and z. So yeah, that's all we are supposed to find in this question. So that's all for today. We'll discuss the other questions on this topic in the next video. So if you're liking the content, then please like, share and subscribe the channel for more such videos. Thank you.